All right, so in this example, what we're going to do is we're going to wrap up this part by taking derivative of the equation of an ellipse, and not only that, finding a normal line and a tangent line at a specific point. Okay, sounds tough. It's not bad. Here's the deal. When they give us a value for x and a value for y, they're giving us two critical pieces of information that we're going to have. Because when we take a derivative of an ellipse, we're going to have a y and an x value running around. We need a spot that's on the graph, not some random place like on a quadratic function or a linear graph that rolls through almost every value of x. There are values of x that aren't used, and we cannot find a derivative at those places. So when they ask you to find the normal and the tangent line to an ellipse, they will give you the values that they want to use, and it should be a value that should be on the ellipse. So you shouldn't have to check, but every now and then you might just make sure. Okay. So what we're going to do with derivative on this guy is, notice we're going to have derivative here, we're going to have derivative here, we're going to have derivative here, but right here in the middle we have a u and we have a v. So we're going to have to use the product rule on this guy. Okay, and you'll be all right, but you just have to pay attention. So let's dive in. The derivative of 2x squared is 2x. Okay? The derivative of x times y is the first times the derivative of the second. And in this case, the second part is that v, and that's just y. So the derivative of y is dy dx. Plus the derivative of the first, which is that x, times the second, which is the y. So he actually turns out to not be too bad. Okay, plus the derivative of y squared. Well, that's going to be 2y times the derivative of y, which is dy dx. And then if you take derivative on the left side of the equation, you also have to take derivative on the right side of the equation. So in this case, we're going to get a big old 0. Derivative of a constant is 0. Okay. Now, collect all your dy dx's on one side, move everything else to the other, and solve this puppy. So I'm going to end up with 2x minus x dy dx minus y plus 2y dy dx equals 0. And I just need the dy dx's together. I need everything else on the other side. So what I'm going to do is move my 2x and my y over. Okay, so this is going to give me negative x dy dx plus 2y dy dx equals negative 2x plus y. Okay, and then factor out dy dx because it's in both terms here. Here it is right here, and here it is right here. So we can factor that out. So dy dx actually can come out here in front. Okay, and then it's going to be times negative x plus 2y. So when I'm working this guy out and I ask you what the derivative of this ellipse is, then we would say that dy dx, the derivative with respect of y with respect to x, is equal to, and then notice down here on the bottom, I've got dy times negative x plus 2y. Guess what? To get dy dx by itself, I divide both sides of the equation by that thing. So I'm going to end up with negative 2x plus y over negative x plus 2y. There's my derivative. And it's important to notice that you have x and y in here, which is why they gave us a specific coordinate with x and y in it. Okay? So if I want to know what the slope is of this guy, then I substitute in those values of x. So I'm going to have negative 2 times x plus y. And so my x is going to be negative 1, and my y is going to be 2. And then also on the bottom, negative x plus 2y. So over negative x plus 2y. Phew, excuse me, goodness. So I'm going to just put in here a negative 1 and a 2. And so my slope is going to be 2 plus 2 over 1 plus 2, 4, which is going to be 4/5. All right, and as long as this is good, I know that my normal is going to be the opposite reciprocal. So if this is my slope, the tangent to my slope is going to be negative 5/4. Okay, and with those two things now, I can write the equation of the line. My line now is not going to be hard to do. Okay, it's going to be y minus the y coordinate, or y plus 1, equals the slope 4/5 times x plus 1. That should be y minus 2. And then for the normal line, I'll write the normal right up here. So we need a perpendicular slope. That's going to be my normal. And so the normal line then is going to be y minus 2 dadgummit, equals the normal now, which is negative 5/4 x plus 1. So that's how we can use these two things to find the derivative of an equation, and we can use it to solve out and find a slope of a tangent line and the slope of a normal. So it's really interesting the way all of this works out. And what we're going to find is if we were to draw a tangent line at this point of negative 1, 2, it's going to have a slope of 4/5, okay, and it's going to have a normal, a perpendicular line to that, of negative 5/4. It's really cool.